last station we'll be going over is station number 3. This one involves radiant or light energy. Our main thing that we will be using here is our light bulb. So, first thing you need to know is we will be using a lighter, a light bulb, and a couple of thermometers. We're going to keep them 15 to 30 centimeters away from a light source so we don't melt the plastic. Notice this light source is approximately 28 centimeters away. So, part 1 is called sunlight and shade. What we're going to do is we're going to have one thermometer in direct sunlight and the other one is going to be in shade. This is in shade and that's the one in direct sunlight. We are going to measure the starting temperature, the temperature after 5 minutes, 10 minutes, and 15 minutes, and then the overall change in temperatures for this. And then we're going to draw a conclusion based on those answers. So I will be using my little egg timer to help us out. And we'll start with the temperatures. This is the starting temperature in the light, right here. I'm going to pick them up each 5 minutes. So that's in the light. All right, this is the starting temperature in the shade. Okay, that's the thermometer in the shade. And I am going to start by turning my light on. Notice my light is shining on my thermometer, directly on it, and my other thing has nothing on it. And then I'm going to set this for 5 minutes. When this goes off after 5 minutes, we will check, and I'll set it for 5-minute increments. All right, so that's the sound it'll make. So 5 minutes from now, it'll beep, and then we'll go there. I'm gonna fast forward. Oh, and the timer just went off. That was 5 minutes. Let us first check the temperature under the light. Temperature is now that. As you can see, it changed. That's the temperature under the light. Start our timer again for 5 more minutes. And then this is the temperature in the shade. All right. So that's that. We're going to leave this here as our clicker goes and our light heats up our thing. All right, the timer went off. Time to check our new temperature, see if it's the same. Oh, look, it changed. This is 5 minutes later, so this is after 10 minutes under the light. And that is what the new thermometer temperature says. So I'm going to place this back under here. Set that for 5 more minutes. In the shade, after 10 minutes, our temperature is right there. This is in the shade after 10 minutes. All right, so we'll leave our other thermometer here. And in 4.5 more minutes, we'll check. All right, timer just went off. That was 15 minutes, 5 more minutes after the last one. So this is the third and final reading. As you can see, temperature is right there. That's after being about 28 centimeters from the light source. All right, and the one that's not in the light reads that. So that is the shade. All right, so those are the two temperatures. So what you should have figured out and filled out was the thermometer in direct sunlight, starting temperature 5, 10, and 15 minutes afterwards, and then the change from the start to the end, and the one in the shade from the start to the end. That's the last one. How does the direct sunlight affect the temperature of an object, and what energy transformation occurred? Once again, you should have your paper with your different energy transformations you should figure out. All right, so now we're going to move to step 2. Step 2 is a nice and easy one. That says you're going to observe a radiometer, draw a diagram of it, and bring labeling the black and white sections of the vein. We're not worrying about drawing the diagram. We're going to place the radiometer. This right here is your radiometer. Notice there's a vein that shows black, and the other sides of them are white. So it's black and white veins. Those are veins or the sides. We're going to place it in light and move it away from the light, and then we're going to see how it changes. We're going to observe something every single time. So we're going to find ways to partially and completely shield it from the light, and then record our observations. So I set up 5 things here. I'm going to start with the radiometer, very close to the light, and I'm going to move my light down and it towards the radiometer. Light is very hot to the touch. So I'm going to move my thermometer so it doesn't touch it. And we're just going to turn this way. I'm going to move my table. I'm going to start with the radiometer directly into that light. So when you have direct light shining on the radiometer, notice what is happening to the veins. I know it's a little blurry with the light. See how fast they're spinning, and notice the speed. All right, that's number 1. Now what we're going to do is we're going to move it a little farther away. And notice what happens when you move it a little farther away. Make your observation. All right, we're going to go a little farther. Step 3. So now we're a little farther from the light. Not that much farther. Let me go another step. Step 4. All right, we're getting farther away. Notice it is still moving. Look, it's slowing down. We go 5. We're going to go all the way over here. So we are still in the lights thing. But notice what happened to our light. Still slightly moving. Not totally slow yet. Now you can go crazy and throw in another one right here and move it all the way to the other side of the table. All right, so first thing I'm going to do is I'm going to stop the sunlight from hitting it. Notice if I block the sunlight, it's going to slowly slow down, because right now it's just using its momentum. And then stop it. Put it down. And notice when it gets far enough away, it does not move anymore. It's trying to move a little bit, but it's not. And then after I push it a little bit closer and closer and closer, once again, if I get it to there, it'll try to move a little bit and nice and slow. And that is the radiometer. So you're going to fill out the questions based on that with the amount of light and your radiometer observations and explain how it affects it. Our last activity is right here. That's the PV cells degrees from vertical. Now in this table, what you're going to do is you're going to go 0, 15, 30, 45, 90, 75, and 60, 75, and 90 degrees. And you're going to angle the light at a solar panel right here. And the solar panel is going to be flat. All right, I'm just going to use this as a reference guide. That solar panel is going to be attached to a motor attached to a fan. I'm just going to use this house to hold up my fan, just because I'm by myself, and normally a person would help me with this. Now you'll be able to see the solar fan move based on the angle I'm going to shine my light at. So when you see that thing spinning, that is your observation, okay? So the fan is key. So I can even move this a little bit closer so you can observe. So you're gonna look for the speed at which that fan is spinning. So I'm gonna take my light and I'm gonna hold my light, all right? I'm gonna hold it at these different degrees. So the first degree is at 0 degrees. This is 0 degrees. So do you notice anything happening to that fan? All right, let's move up to 15 degrees. And you can give it like a little spin to see if it has any life here. I'm gonna get a little closer. So at 15 degrees, you can see it's kind of moving a little bit, right? Not terrible. Let's go to 30. 30 is a little bit closer. All right, so 30, you can see, I can actually feel a breeze on it. All right, so I'm gonna pull it away. Now I'm gonna go to 45. So this is 45. You should see something change with the fan. All right, we're gonna go to 60. This is 60 degrees. All right, stop it. 75. All right, and then finally 90, which is directly above it. Oops, 90. All right, so you should notice something happening to the fan every time I change that. All right, so this is the fan you were supposed to be looking at. You were supposed to see how it changed. So you're gonna enter in pretty much all the observations you do. By observation just means like fan speed, and then describe the energy transformation used from your observations that support your conclusion. And that really concludes station 3, which is our light station and our use of radiant energy. Great station to use. What you should do if you have extra time is you should read the what's happening section here, which tells you about sunlight and shade, how the radiant energy turns into heat, how a radiometer turns radiant energy into motion, and it also tells you how the solar panels turn radiant energy into electricity. So actually, these are PVCs, photovoltaic cells. All right, so excellent job, and I'm glad you were able to do this.